before we start the next example, let's talk about the extreme value theorem. Now, the extreme value theorem just says that if we have a continuous function on a closed interval, then we have to have an absolute maximum and an absolute minimum. All right, so if you have a function, if it's continuous and it's defined on a closed interval, then there's definitely going to be an absolute maximum and an absolute minimum. All right, now in example 3, we're just asked to sketch a graph of a continuous function on a closed interval from 0 to 5 that has an absolute maximum and an absolute value, absolute minimum given, right? Has the given absolute maximum and the absolute maximum and minimum. Okay, so all right, let's just look at this first one. All right, so we have we're told that we have an absolute maximum at 0, 3. So let's just put that point on there. Okay, that point has to be on the function, and we have an absolute minimum at 3, -2. Okay, so I'm going to graph that point. Now, we want a function that is continuous on the closed interval from 0 to 5. All right, so we want the function to be continuous, and we want it to be defined for the whole interval between 0 and 5. So I'm just going to sketch what that might look like. All right, so I'm just going to kind of just sketch a continuous function. Maybe it does that. And now that point at 3, -2 has to be the minimum. So we're just going to increase from there, right? So maybe it goes to there. We'll say that's the endpoint that ends at 5, 0. All right, so that was one example of what it could look like, right? Now, of course, you could have other possibilities as long as it's continuous, right? It could sort of wiggle and or this endpoint might go higher, but that's just one example of what it would look like. All right, so let's look at the next one. Here we have an absolute maximum at 1, 3. All right, so I'm going to put that value, I'm going to mark that value on the graph. That's an absolute maximum. And then we have an absolute minimum at 5, -2. Okay, so that's at the endpoint of the interval. All right, now we don't know, this function has to be continuous and it has to be defined from 0 to 5, right? From x = 0 to x = 5. So I don't know where we need to start, but maybe we start here. It just has to be some point lower than 3 because we're told that 3 is the absolute maximum. So maybe it increases to 3, and then we could do whatever, right? It could look like that. Maybe that might be one example of what this function might look like. Okay, so now it has to be a function too, so I can't do anything too crazy where, because if it's a function, then every x value has exactly one y value, so I have to make sure it looks like a function. That's the other criteria. All right. And then, all right, what else have we got here? We got this one, we have to have an absolute maximum at 4, 2. 4, 2. That's our absolute maximum. And then our absolute minimum is at 1, -2. Okay, so we have these 2 points. And it has to be continuous and defined on the interval from 0 to 5. Okay, so we just need to connect up those points. This one has to be a minimum, so it has to probably decrease there, and then this is an absolute maximum, so it has to increase to that value, it has to decrease beyond that, so maybe it ends here. Okay, so that's one example of a function that's continuous on 0 to 5 and has the given maximum and minimum values. All right, so I will meet you in the next video for the next example.